welcome back. In today's video, we're talking about capacitors again, the second part of this topic. First off, I would like to apologize for the video. I have been looking back and seeing the video resolution, or it's not in frame. Hopefully I'll be getting this fixed with this video and so on in the future. I do apologize for that. And yeah, let's just get right into it. Today's video will be talking about capacitors, as I said, and we'll be talking about their uses and why are they so useful, what can you do with them, and so on. Before that, I'd like to talk about capacitance reactants. So we spoke about capacitors in a DC setting, but what if it was in an AC circuit? So remember, DC is direct current, AC is alternating current. So with direct, our signal is expected to be like that. So that's DC. So if you just picture our signal like that, and within AC, I can draw a straight line, our signal is expected to be like something like that. It's not entirely, but you get the general idea of it. So when a DC voltage is applied to the capacitor with a light bulb, so I'm going to draw this circuit here. So here's our capacitor, here's a bulb, using conventional current for this. So when we apply it, our light bulb will lit up. So our conventional current is traveling through here, it's going down here, you find it's lit up. But though after a short time, we'll find that this bulb is turned off. Why is that so? As mentioned in the last video, this is because our capacitor is practically at full charge, and so no more current flows. And this in turn behaves like an open circuit. So this will be full charged, this capacitor, it's just full charge, and this will no longer light up. But what if we applied an AC voltage source? So our voltage will fluctuate, causing the capacitor to charge and discharge. So this, and here this is our positive, this is our negative, and this is why it's causing it to discharge and discharge. So if we drew the line here, that's 0, maybe that's 5 volts, that's negative 5 volts, and that's our AC. So what this means is that the faster this fluctuation, the less the capacitor opposes the current or electrons that are flowing through the circuit. So if we took the conventional current is going through here, and if it's fluctuating, it's not going to oppose as much because it's faster charging, discharging. But however, the slower the fluctuation, the greater the opposition, because it's charging, it'll take a while to discharge again. So what is this? What is this resistance, this opposition? We call this capacitance reactance, and this can be found using this formula. So we take Xc as our capacitance reactance. That's equals to 1 over 2 pi Fc. So Xc equals capacitance reactance, pi equals pi, so 3.14, the general, you get it. Our F is our frequency, and C is our capacitance. So because of this, and now that we know this, our capacitors behave differently depending on the voltage and frequency applied to them within an AC circuit. And this gives rise to many of their different uses. So I did briefly mention these uses, but I'd just like to go over them further. So filters, for example, they are capable of passing or amplifying certain frequencies whilst attenuating other frequencies. Capable of extracting the important ones from the undesirable ones. So with filters, you know, they give rise to many different purposes, and these filters are capable of amplifying and extracting. And these filters would include some basic ones like our low pass, our high pass, our band pass, and notch, which are some commonly known ones. And then as stated before, we can get certain frequencies from them depending on what we desire. So for a low pass filter here, we block this part of the filter is blocked. And for a high pass, we just want this part, so this part is blocked here. For a band pass, maybe we just want this section right here, this part gets blocked. And for a notch filter, we don't want this part or this part, we just want these. And as you can see from this, you can already see the massive capabilities of this within audio electronics, and especially radio frequencies as well. There's also not just that, especially with DC power supplies, with switch mode power supplies, we can use these filters to take out the noise from maybe our main circuit or from the switching noises present that are maybe generated. So we also briefly spoke about decoupling, and these capacitors are usually placed in parallel with the power source and the load, as you can see here. And these decoupling capacitors usually has two main functions. As mentioned before, they act as a local electrical energy reservoir because capacitors oppose quick charges voltage, and these capacitors can provide energies to keep the voltage stable whenever the input voltage suddenly drops, perhaps. This helps smooth out ripples. So if you imagine from our 10-volt supply, for I don't know, for some reason it's acting like that. For example, we want to smooth that out and probably get a more, just something like that, a more straight, direct current to what we're used to seeing. And this is what this capacitor does to help smooth that out. So it could be more drastic cases where, for example, our, let's just use the same. So this is 10 volts here. Perhaps, our load is a microcontroller, for example, and it requires 10 volts to run, let's just say. And, it turns off at 9 volts. So as you can see, we're going to get this, every time this hits 9 volts, it's not getting enough voltage, and it needs something to help with that. And this is what this capacitor is there for. It also helps out to filter out noise. So because this capacitor has less reactance to high frequency signals, which allows it to pass AC signal and block DC signals. So it's very useful for that. And since this is more or less related, the bypass capacitor are stated in the name bypass and are routed to ground. So this thing right here, it's also just a similar name for it. You may see it just called bypass cap or whatever. And this is to pass AC noise through it to ground. So decoupling capacitors can also be called bypass capacitors. Just keep that in mind. So last but not least, we're going to be talking about coupling capacitors. And I've got a little circuit here, common emitter amplifier, and this would be our V and our AC signal going through here. And we want to amplify this circuit. And what you'd see here is this little circuit. Oh, come on, it's much larger. And I've mentioned this so many times during this video, but it's very important that you just need to know that a capacitor blocks DC and allows AC in this purpose. So when it's placed within this circuit, what we're doing is trying to filter out that DC, in this case, like the noise that we don't want, so it doesn't carry on to our next circuit, which could really heavily damage, and we get unwanted noise and disruption in our circuits. So because, like, for example, if we had this AC signal here, we've got like a DC noise was to come through, and if we didn't have that, we're going to carry that on to our next, for our circuit. We don't want that, so we place that capacitor there to avoid this problem. So it's very useful, really. And this was just that really sums it up on the main purposes of well, not main, well, yeah, main purposes of our capacitors and what they could be used for. Hopefully in the next video we'll be talking about inductors, and that will sum up our basic electronic components. Hopefully doing some projects after that, showing you guys on how to do them, see what ideas come to mind. So thank you for watching.